below, we have learned the derivative, the definition of derivative. The definition of derivative is the ultimate tool to determine if a function is differentiable at a specific point. Okay, let me say this again. The definition of derivative is the ultimate tool to determine if a function is differentiable at any given point. Okay, so that is the very, very important definition. Okay, so let's see what is the definition. So for any function that's given, okay, the ultimate definition, okay, when h is approaching 0, f of x plus h, I will use a plus h minus f of a divided by h. If this limit exists, right? If this limit exists, then f is differentiable. As you can see, f is differentiable at point A. And of course, if this limit does not exist, then f is not differentiable at A. Okay, so that's the definition. Now, when we look at number 4, there are 2 questions in this number 4. Ask us to determine whether f is differentiable at 0. Okay, so what is our tool? Okay, our tool is the definition. Okay, so I'm going to take this as example number 1. The function we have here is f of x equals to and over here, right? So we have x times sine of 1 over x. If I'm just copying this question, if x is not a 0, 0 if x is 0. If x is 0. Okay, so determine, right? We want to determine where to determine if f is differentiable at 0. Okay, so we are to determine that. Okay, we said that checking the limit is the ultimate tool. So we're gonna start with the limit checking. Okay, and since h is approaching 0, h is not 0. So when we do f of a plus h, in our case, a is 0, a is 0. So when so 0 plus h is h, right? So f of h when h is not 0. So f of h when h is not 0 is going to be, we're going to substitute x by h. So this is h and this is h. Okay, f of 0, of course, equals to 0. So all we have to do is just put it back, put it in the definition to see if there's a limit. Okay, f of h is this piece. Okay, remove that f of 0 is 0. To simplify, we got the next step, which is just like that. And this h and that h will reduce. So we will end up with just sine 1 over h. When h is approaching 0, 1 over h is approaching positive infinity or negative infinity depends on which side of h is approaching 0. So as sine 1 over h is fluctuating between -1 and +1, so this limit does not exist. If this limit does not exist, it tells us by definition, this f is not differentiable. Okay, so it is not differentiable at 0. Okay, let's look at the second one. Example number 2. Right, so we have almost the same function, except there's a little minor change. This is x squared. Okay, so we're still checking to determine if this new function is differentiable at 0, right? So everything is almost the same, right? F of h, okay? So we're going to apply the definition. F of h this time, right? F of h, when h is approaching 0 but not 0, is going to be h squared multiply sine of 1 over h. Okay, and f of 0, of course, is 0. So now we can just plug in. F of h will be replaced by its equal, and f of 0 is 0. So now once again, because h is approaching 0, but h is not 0, so we can reduce the h, right? We can remove this 0, h and h will be reduced. So we got h multiply sine of 1 over h. What is the limit for this piece? Okay. Can we do direct substitution? No, we cannot, because h is not in the 0 is not in the domain. So what we can do is that we can use absolute value. Okay. We're going to take absolute value of this function, and that's going to be less than equals to the absolute value of h, right? Multiply the absolute value of sine 1 over h. Sine of anything is always less than equals to 1. So this just be left with the absolute value of h. Okay, so here I'm going to put a because, right? Because sine of anything is less than equals to 1. By anything, we meant anything, okay? So by this time, we know that sine of h of sine times 1 over h is less than equals to the absolute value of h. And that also means that this piece is between negative absolute value of h less than equals to and less than equals to absolute value of h. So by this time, we have constructed a function, right? We have constructed two functions. One is above, one is below, right? One is above, one is below. And the limit as h approaching 0, absolute value of h is 0. So by squeeze theorem, right? This limit, which is squeezed in between, is going to be 0. So you can see squeeze theorem can be used here. Okay. So if you look back at these two examples, we use the same criteria to determine the function is differentiable as 0 or not, but depending on the function's property. The first one is not differentiable as 0. The second one is differentiable as 0. And we have proved that, okay, using squeeze theorem. All right, that's all for this recording. Thank you for watching. Goodbye.